next slide. After that, we started doing some work. It didn't have much traction. It was way ahead of its time. But in 1988, we started in Costa Rica, which I have to say is the poster child of computers in education. Because since that time, there's been continued work. I'm not sure why Costa Rica hasn't had more influence on the region, but we think of it as the best example in the world of the use of computers in education. It's been very sustained. It's gone through many administrations. Yes, nothing is perfect, but it's the best we've found and the best we've worked with. Next slide. In the 1990s, I was convinced that telecommunications was what we had to do. We had to bring telecommunications to the most remote parts of the world. This image is in Kashmir. It's on the Indian side of Kashmir. We were using what was not called Wi-Fi, but is today. This is a form of 802.11, which can be focused with a Pringles can, if you eat potato chips, very low cost and can go 50 miles. And we were going over the mountains to connect the Pakistani side of Kashmir with the Indian side of Kashmir because the adults were messing everything up. But if the children could talk to each other, we thought that would be a good idea. And we did a lot of work in this area. Next slide. And it was about 5 years ago that I realized that telecommunications is going to be basically resolved by so many different concurrent approaches. You have heard in the press and read about Wi-Fi, WiMAX, 3G, satellite systems. There's just a lot of things happening. So I can argue with some and say this would be a better approach than that, and make little differences, but there's nothing I'm going to do that's changing it. The regulatory regimes are changing it. Industry's changing it. The cell phone industry has grown, so there are already 2 billion cell phone users. That's basically that's about 30% of the planet is already connected with cell phones. Now, sadly, those cell phones are voice, but it's moving in the right direction. So you don't need me to change telecommunications. That's not the problem. That's the problem. The laptop. And the reason it's a problem is that they just cost too much. And unlike telecommunications, they're not elastic. And what I mean by that is, if I connect a village with, let's say, 1 million bits per second, I give it connectivity to this village, and 200 kids share it, it actually isn't bad. And now suddenly there are 220 kids, it's okay. 225, it's okay. In other words, it doesn't deteriorate and there's no incremental cost. Whereas I give 1 laptop per child and there's 200 kids, that's one thing. If there's then 250, I need 50 more laptops. It is not elastic. I have to keep spinning out more laptops. And why do we want laptops? We want the kids to have a seamless education between home and school, between play and work, to use this to make music, to use this to read books, to use this to look at movies, to use this to play electronic games, to do the entire spectrum. And that's very, very important because the laptop and portability nature is critical to what we do. So, next slide is just one of 2 inspirations for me. It's something I did personally in Cambodia in a village where the average income is $47 a year. No electricity, no water, no telephone, no television. And in fact, there are now 5 villages involved, and one of them doesn't even have a road. You can't get there. Actually, this time of year it's very difficult to get there because it's the rainy season. Other times of year you drive or motorcycle through the riverbed, which is dry in those seasons. In this village, the first English word of every child is now Google. That's their first word. And it might interest you, I'm sorry that my example is Brazil and not Argentina, but the truth is that the kids in this village, the first thing they did was use Google to go look up the football players in Brazil. Okay, that's the first thing they did. I'm not inventing that. The first night we asked them to take them home, the parents insisted that the kids not open them because they might break them and they could tell they were expensive. We had Wi-Fi in the village, so if they took them home, they'd be connected. The second night, they took them home with a message, which nobody could read because the parents are all illiterate, but they believed that the message said something that allowed the kids to open them. And the kids opened them, and the parents loved it because it was the brightest light source in the house. No electricity. And so when the kids opened their laptops that are powered by batteries, it illuminated, these are one-room houses, just illuminated the room. So talk about a metaphor and reality sort of being a little bit hair-raising. I said to myself, could this scale? Or is this just a pretty picture? Where somebody, in this case myself, had enough money, went to the village, did something charitable, and it's kind of a postcard. Well, in parallel, in the year 2002, Seymour Papert persuaded the governor of Maine, small state, to legislate one laptop per child. This became law, that the state has to provide children, in this case in the middle school, because they want to start with all the children in the state, by law, a laptop at the beginning of the year. And they've been doing this now for 3.5 or 4 years. They've been doing it, this is the end of the 4th year. I think it's fair to say that 80% of the teachers were against this. And if they weren't against it, they were at least apprehensive. 8-0, most of the teachers. But the governor was a very strong governor, pushed it through legislation. Teachers said, no, we want higher salaries, we want you to paint the school, we want new furniture. No, it was pushed through. And today we cannot find one teacher, not one, who is anything but absolutely enthusiastic about this project. They tell us things like, teaching is a totally different experience. They've never had such excitement in their class. The teachers are involved. Sorry, the parents are involved. The parents attend parent-teacher meetings. The parents are suddenly much more engaged in their kids' education. Discipline problems have gone down. Truancy has gone to almost zero. And the one I like the most is that they have to turn the servers off at night because the teachers are getting too much email from the kids asking them questions. Okay. Now, if that's not a good sign, I never wanted to ask the teacher questions because you looked like a sissy. You didn't want to go and ask the teacher questions after class. But now, when you have your laptop, you can send in the privacy of yourself a question to your teacher, and the teachers are, in fact, in this case, suddenly swamped. So all of these things that were happening in Maine and this thing in Cambodia, we said, okay, let's just do it. And I will show you some images of what we've done. The first image happened because the governor of Massachusetts, can we go to the next slide? The governor of Massachusetts had heard about this and decided he wanted to do it in Massachusetts. This was about a year ago. So we were already doing some of these sketches, sort of looking as to what would a $100 laptop be like. And now we may have to go through some of these a little faster. The next slide is the one we built as an image for the governor of Massachusetts. And this image is very important because you see on the side of it a hand crank. 50% of the kids do not have electricity worldwide. At home, they certainly don't. And so you can't build a laptop that plugs into the wall and charges up because there's nothing to plug into. So from the very beginning, we said this computer has to work on human power. You have to be able to crank it, pull things, pedal it, do whatever, which is very, very fundamental and was in the very first concept. Next slide. This is the one I showed with Kofi Annan in Tunis. And the UN has joined us as a partner, and this is the machine that we showed. The yellow crank on the side got so much worldwide press. In the current machines, the crank is on the AC adapter. It's not on the machine itself. And I can't tell you how many people send us emails saying, "Where's the crank? The crank's disappeared." Well, the crank hasn't disappeared. The crank has moved off the laptop and it's on the side. It's on the AC adapter, which is actually particularly good because now you can give it to your baby brother or something to crank for you, or you can, do something else with it. But it's not attached to the machine, and that was a very good decision. But here it was still attached to the machine. And because Kofi Annan was involved in announcing it, the world interest just went through the roof. It would be the number of countries who have not asked is a very short list, and it really launched the project. The next slide is sort of where we started to go, still with the crank on board in this image, but how could you make something that was very light and had, and this was the first image that had it, literally little rabbit ears that come up. Because you have to provide these connected to the internet. And for some reason the press misses this. In fact, this issue, the one that just came out this week of Wired magazine, has a whole story on the $100 laptop, and at the end of the story they completely missed the point and actually said the opposite, that these aren't connected. These are connected. They come connected, pops out of the box, and you're connected to the internet. Now, how do you do that in a remote and rural place? This place doesn't have telephones, so how are the kids going to be connected? And the answer is the following. Pretend you were all kids in this audience and you all had a laptop. And the way the laptop down here in the front right side, my right, of the room, and the back left, the way they communicate is by her laptop talking to hers, and it goes, and it gets like messages getting passed through and finally gets over there. You all, whether you're kids or an audience, make a network. It's what we call a mesh. And as long as a child is within 600 meters of another child, that child is connected. And if a child bicycles home 2 or 3 kilometers, so the distance is too far, then we give the child something about the size of this glass of water that the child can nail onto the tree that boosts the signal to get it to the child's house or to the little hamlet that is far away. So now let's say you're 500 children all connected. If I buy a satellite link commercially, this is commercial prices, a satellite link, I can connect to some point for, let me invent, $500 a month. Pretty expensive. But divided by 500 children, that's $1 a month. So as long as that is on the network, then everybody's on the network. And if you're in an urban area, you do it in a different way. You can do it with WiMAX and so on. But it's very important that you have one point that goes back. And if you look at the economics, the laptop costs, in rough numbers, $2 a month. And the connection is $1 a month. So you're talking $3 a month per child. And most countries in your region are spending in excess of $500 a month. Sorry, $500 a year on education, probably closer to $1,000. So these numbers are not so outrageous if you're looking at it from the economic point of view. In fact, the cost of textbooks in most countries is higher than $3 a month, too. So, quickly moving on. Next slide. This is basically the current machine. It turns into an electronic book when you fold it up. You'll see it in a moment. Next slide. We'll go through these very quickly. This is the current machine. I'm sorry I don't have one with me. It's so beautiful that this is like an iPod. Trust me, these are cherished, and they are really very different because most of the times when people build low-cost